Today I'm going to continue about sets few more topics which are needed, and also I'm going to talk some common sets which we'll be using always in mathematics or even in next few chapters like functions or limits, other chapters throughout. Whenever we deal with functions, we use few kind of sets which are special kind of sets. For example, let me start with set of all natural numbers. First one is set of all natural numbers. Set of all natural numbers, and I represent it as n. This should be thick n. So in black letters it will be represented n. Not black, it should be thick and n. So not normal n, it should be thick. So the first one is set of all natural numbers and also the set of all integers. These are special sets, I'd say. Set of all integers. It is represented by z. Again a bolded z. A bold z. Similarly, integers. It should be integers. Set of all integers. And also set of all rational numbers. Set of all rational numbers. I can represent it by q. It is commonly represented as q. Again bolded q. And set of all real numbers. So this is represented by R. So these are all sets. So now I am going to show a particular relation between all these sets. We know that real numbers, we have been read in class 9, that these are all real numbers, rational numbers, or how they are related. This sets how they are related, real numbers. So for example, I want to begin with a big circle. Consider I am taking a big circle. So this, if I take it as real numbers, these numbers inside a circle are real numbers. So now what are rational numbers? Rational numbers are which I can represent any numbers in the form of a by b fractional form, where b not equal to 0. So if such kind of numbers are rational numbers, so I can take that rational numbers, then comes the rational numbers. This is q plus q. Similarly, in rational numbers, if b is equal to 1, they are integers. I mean b is equal to 1 means if a by b are, if a is divisible by b, a is divisible by b, then a by b will be integer. A by b will be a number, right? It will be integer, means 0, minus, from minus 1, minus 2, minus 3. These are negative integers. Also 0, 1, 2. These are all integers. 3, 4, etc. and minus 2. So inside rational numbers, they are integers, right? I hope you all get it. Integers are represented by z. So what does this imply? That all rational numbers are real numbers. So this circle inside, because if you see q is inside real numbers, so all rational numbers are real numbers, but not all real numbers are rational, because there are irrational numbers also, as we know that square root, root 2 or pi, or those things are irrational numbers, they come separately. So these are rational numbers. So inside rational numbers, there are fractions which cannot be expressed as integers, so which are not exactly integers, like zero point 0.5. If I take minus zero point 0.3, these are not integers, right? These are decimal numbers. So if I take, these are decimal numbers with 1 point precision, so these are not integers clearly. So these all come under, although all integers are rational numbers, but not all integers are, not all rational numbers are integers. There may be fractions also. So similarly, inside integers, if I remove the negative numbers, like from minus 1 to minus infinity, if I remove it from integers, then even including 0, if I remove this, then these 1, 2, 3, 4 until infinity, those are natural numbers. So now you have to remember that all natural numbers are integers, but all integers are not natural numbers. So I hope this diagram makes sense here, because actually this should not touch here. Let me correct it. So this is this kind of diagram which now you saw, this is called as Venn diagram. So why I am stressing on this point is that we all know that, so now inside real numbers there are so many, there are rational numbers, there are integers, there are natural numbers, all come under real numbers, right? Then you will also see something called as, not all numbers are real, because if you know that square root of minus 1 is not real, it does not exist, but this is complex, actually this is not real number, so this is imaginary numbers, imaginary value. We don't know the value of square root of minus 1, so this is imaginary. Square root of negative numbers, for example, we don't know, those are not real numbers, so that is a different thing. Not real numbers, not real, so this will come separately, not real numbers, so these are imaginary numbers or complex numbers. So if I take this manner, and also there are few more given in the textbook, but I would say that these four are the most important ones, and this will be very useful, and especially among these four, z and r, real numbers, are much important, very much important. Integers, so these two are very important. So you have to very clear with this four sets. So this form of representation is Venn diagram, and also it is much easier to comprehend. Now it have been very clear, right? I will write the statement. I will draw this diagram again, and I will write very clearly, because this is very important. Just a second. So let me draw a big diagram. Generally I am comfortable with circle, a big circle. So this is a real number. Then comes rational numbers. Yes, I represent it as q. In rational numbers, we get integers. Then in integers, natural numbers will come. So this is what is there. So this is a Venn diagram. So this implies that I'll write the statement. All integers, all natural numbers. Sorry, all natural numbers. Let me write. All natural numbers are integers, right? This is very clear, because if you see that circle of Z, all natural numbers are inside the circle, right? So all natural numbers are integers. Yeah. All natural numbers are integers, but again, not all integers are natural numbers. Vice versa is not true. Not all integers are natural numbers, because integers may include negative numbers, but negative numbers don't come under natural numbers, right? So negative numbers, natural numbers, this is the first point. Then second point is that all integers are rational numbers, right? All integers are rational numbers, because integers can be expressed in the form of a by b. All integers are rational numbers. Rational numbers. But not all rational numbers are integers. Not all rational numbers are integers. So I think this statement would have been very clear. This, and also I have given an examples also. So similarly I can write all rational numbers are real numbers. All rational numbers are real numbers, right? But not all real numbers are rational. Because real numbers includes rational and irrational numbers, right? So, but not all real numbers are rational. Because for example, root 2, square root 2, root 3 and pi, those are all irrational numbers. So this is a conclusion, and also now how it is related to sets. So far I didn't talk anything about sets, right? So I have just given a notation R, Q, Z, N, and there is a set of real numbers, set of this things, that thing. But now my main motive is that why I am drawing this Venn diagram and drawing this stuff. I have written the heading subset, right? So what is a subset? So I can write as follows. I can write N as subset of real number, right? Because all natural numbers are real numbers. So because in a set of real numbers we can include all natural numbers. All natural numbers are already present in a set of real numbers, are part of the set. So subset. Similarly I can write that natural numbers is also subset of integers, right? Because in a set of integers, natural numbers are also part. So subset is represented like this by this C symbol, extended C symbol. Similarly, you can write other three also. For example, Z is also, integers are also subset of real numbers. You can use that. And this is not C, this should be elongated. So integers are also subset. And also q is nothing but rational numbers are also subset of R subsets. So these are subsets, right? I hope you got the understanding of subset. What is a subset? So all elements of this set, which I call it as subset, are included in the superset. This is called superset. R is superset. Here R is superset. Superset of other three, superset of Q, Z and N. So this formal definition, now I am going to come here. I use epsilon. I use a letter called epsilon. That, for example, how I'll define it as a subset. Generally, if A is a subset of B, if generally this notation, if small a, you know that sets are represented by capital letters and elements inside it are small. I've already said this in the previous video. Belongs, this epsilon symbol is belongs. A belongs to set A implies that A also belongs to set B. So this means implies. So in other words, if A is a subset of the, whenever A belongs to B, then A should also belong to B, this small a, this element. So if particular element is present in a subset A, is set A, it should be present always, it should be present in a B. Then I can call that element, the corresponding set is a subset of B, right? So I hope this definition is confusing. That's why I don't want to that much. Understanding is required here. So there, and also this notation is important because it is very frequent we use. So implies, this is symbol is implies, and epsilon symbol implies that belongs. Epsilon symbol belongs to A, belongs to small a, element belongs to A. So for example, if I take natural numbers, for example, if I take natural numbers, 1 belongs to natural number and 1 is also a real number. Similarly, 2 belongs to natural numbers. Similarly, 2 is also a real number, right? So in that way, all elements inside natural numbers, 1, 2, 3, all that same elements will also be there in R. And also R will have more than natural numbers, like other than natural numbers, negative numbers or other numbers also. So this is what is subset, concept of subset. And now what is empty set? One more type of set is empty set. Now empty set. What is empty set? If I ask, for example, if I ask V is a set of numbers, for example, set of X such that X belongs to real number. Now again I am using the notation. And such that X belongs to real number and X is equal to square root of minus 1. So this set, you know that if X is a real number, then we know that square root of minus 1 is not a real number. So this is not a real number. Definitely this is not a real number. So I can say that X does not exist, right? This set does not have any value. I can represent this set as V or phi with phi or empty set. Empty sets are represented like this. So This is represented 5. You can write 5 outside or inside, doesn't matter. So this is a set is empty. Similarly, if I ask such that find one more example I'll give, if this seems very abstract. V is equal to x such that x belongs to natural numbers and x is equal to natural numbers, and also x is equal to x by 3, where x is varying from 2 uh, 0 to 2. So now if you substitute the x, for example, if I substitute okay, let me change the variable. No, let it be there, x equal to x by 3. No, it should be another variable, y. For example, y. V is equal to y such that y belongs to natural number and y is equal to x by 3. So where x is varying from 0 to 1. Natural number, right? So now what I can tell? 0, y takes value 0, 1 by 3, 2 by 3. So this set y, values of y does not belong to natural number. As you can see, this 0, 1 by 3, 2 by 3 are not natural numbers. So this set is empty. I can say this set is empty. So there are no elements in the set. So that is empty set. So I am not going to other stuff. I will talk about interval. Now open and close interval. So there are 4 types of interval. Representation. For example, there are 2 points. First one is that if I want to go from A to B and A be not included, so it is A comma B. For example, I give a natural number. Set of natural numbers varies from what? In terms of 4, I can say that 0, comma, infinity. Because natural numbers are never 0, right? Never 0. 0 is not included in natural number. Similarly, infinity, always. Infinity, we don't know the value of infinity. So it should be always open bracket. So these are natural numbers, right? So we can represent like this. Intervals are, you can describe the subsets of R. You can describe the subsets of R using these intervals. So if we represent open circle, then this is both sides are open interval. Now one more thing is, now there are closed interval. If I represent AB, so this can be represented as closed bracket, square bracket, A comma B. So this implies that A and B both are included in the set. So for example, if I take the integers between 0 to 0 to 10, so I can write that includes 0, 1, 2, 3 up to 10, right? This goes, so 0 and 10 both are included. So this kind of set is closed interval. So both sides are closed, right? Both sides are closed. So similarly, one side can be closed and other side can be open. This is common when other side is infinity. Like if I take whole numbers, you know that I can represent whole numbers 0 to infinity. So this is what, this is closed bracket and this is open bracket. So this infinity is not included, 0 is included. Similarly, if I write, this can be open and this can be closed. So A, B. So open is represented by a circle without empty circle and filled circle with the closed interval. So I can write as this as form A comma B. Sorry, this should be no. A, B is a closed interval. square bracket should come. So these are four types, both open, both a comma b are both are closed. One is open and first one is open and the second one is closed, and also the first one is closed and second one is open. So this kinds these are important. I am going to say why these are important. At this one, maybe this, because this we need in functions. We are going to see in functions in next video. So this is all about intervals, and also I am going to close the sets with this. Now I am going to continue with the functions in the next video. Thank you.